In this lesson, you will learn how to solve quadratics by undoing the operation. We will use the square root principle, which says if x squared equals a number, a just represents a number, then x is going to equal the plus or minus square root of a. You will need plus and minus, because let's think about if we have x squared equaling 36. Well, if x is 6, because x squared, let's go ahead and put in that 6. 6 squared means 6 times 6, which is 36. But x could also be a negative 6. So negative 6 squared is like negative 6 times negative 6, which is also 36. So there's where you're going to need plus and minus when you're solving and taking the square root. Let's look at our first example. We have x squared equals negative 144. So to undo this operation of squaring, we would take the square root. So the square root of x squared will give you x, and then we'll do the square root of negative 144. Don't forget to use plus or minus square root. So x squared and square root, those cancel one another out, leaving you just with x. Plus or minus, the square root of a negative gives you an imaginary solution, and 144 is a perfect square. So the square root of 144 is 12, and then don't forget your I for the imaginary solution. So our two solutions, we have a positive and a negative. We'll write them in set notation. The smallest one goes first, so negative 12i, positive 12i. Those are our solutions. Let's look at number 2. Here we have negative 8 plus 2x squared equals 0. To solve this equation, we're going to undo the operation. So we'll first start with this negative 8. We'll need to add 8 to both sides. Those will cancel one another out, leaving us with 2x squared. 0 plus 8 is 8. Again, we need to undo the operation, so here we're going to divide by 2, leaving us with x squared equals 4. 8 divided by 2 is 4. And then finally, we're going to take the square root of both sides. Squaring and square roots are opposite operations. So squaring and square root cancels, leaving us with an x. Do not forget to take plus or minus square root. That is the square root principle. You do need the positive and negative square root. So we have plus or minus. 4 is a perfect square, so the square root of 4 is 2. So our solutions listed least to greatest. We have negative 2, comma, positive 2 in the set notation. Let's look at our next example, number 3. Here we have x plus 10 quantity squared minus 24 equals 0. So again, we're going to solve these by undoing the operations. So notice first this plus 10 is protected with the parentheses that is squared. So we'll wait and do that here later. But let's undo this minus 24 by adding 24. So we have x plus 10 quantity squared. The 24's cancel one another. 0 plus 24 is 24. So now we need to undo this squaring, because again the plus 10 is protected by the parentheses that is squared, so we need to undo that by taking the square root. Squaring and square root cancels to leave that x plus 10 by itself. Again, remember to take the plus or minus square root of 24. So we have x plus 10 on the left, plus or minus 24 is not a perfect square, so do your prime factorization to see what we can simplify it to be. 2 goes into 24 12 times. Divide by another prime. 2 goes into 12 6 times. Divide by primes until you get to 1. So we have a pair of 2's, so those would come outside as a 2, and 2 times 3 stays inside as a 6. Simplifying that using prime factorization. We need to continue to solve by subtracting 10. So x equals, it's best to put this negative 10 first because we're going to add and subtract plus or minus, that's what that is, the 2 square root of 6. So negative 10 plus or minus 2 the square root of 6. The 10 is not plus or minus. It's the 2 square root of 6 that's the plus or minus. So be careful to keep the sign with the number that it goes with. For our 2 solutions in set notation, the smaller one will be the one where you subtract away the 2 square root of 6. So we'll have negative 10 minus 2 the square root of 6. And then the larger one will be where you add. So negative 10 plus 2 the square root of 6. Again, set notation is always least to greatest. And let's look at our last one, number 4. Here we have x minus 9 quantity squared equals 64. So to undo these operations, we're ready to go ahead and take the square root since our squared is here. Squaring and square root cancel one another. Remember again to take the plus or minus square root. Always have plus and minus, or else you'll only have one solution, which will cause you to miss the problem. It does need 2 solutions. So x minus 9, because squaring and square root cancel, equal plus or minus 64 is a perfect square, or if you need to do the prime factorization to see that it does simplify completely, square root of 64 is 8. We need to now add 9 to both sides. So x is going to equal 9 plus or minus 8. Again, remember the plus or minus goes with the 8, not the 9. So we write it this way, 9 plus or minus the 8. So to get your 2 solutions, you're going to take 9 minus 8 and 9 plus 8. 9 minus 8 is 1, so that's the smallest solution. 9 plus 8 is 17. That's the larger solution. Notice here our solutions are not just opposites of one another like we saw in the first 2 examples. Sometimes that does happen. We have solutions that are opposites, but not always, especially in this case here where you're taking 9 plus a number and 9 minus a number. That will give you 2 different solutions that are not always opposite of one another.